This is the 2014 AB FRQ test, question number 4, part D, a related rate. So in the original question, we have a train running back and forth in the east-west direction. Train's A velocity is measured in meters per minute, and you have the V of A, which is given over here, where time T is measured in minutes, and selected values of V or A have given. And what else do we know? Let's see. In part C, train's A position is 300 meters east of the origin station. So we're going to have the train station right here. And so the train's going to be 300 meters east. And the train is moving to the east. So the train's moving that way. And let's label some stuff here. This distance here is 300 meters. And this is when time t is 2. And we know the velocity of the train, which is 100. We know that because it's told to us there. And we'll interpret that. So as we read in part D, train B travels north from the origin station. The train starts north. You know what? I'm going to have to scoot all this down because we have a train above all of this. So let me move this lower. And we have another train. The second train B travels north from the origin station. So I have to draw a train up here. It's going northwards. That same time t equals 2. I will do this in our gold. So this distance here is 400 meters north of the station when t equals 2. And let's keep going here. Okay, we have a few things we got to take care of. So what's changing? This is a velocity of train A. Some distance is changing over time, and I'm going to claim it's this distance. So in creating this triangle of the station, we're going to call that distance x. You can call it A for train A, B. I like x because it's the x direction. And then this distance from the train to the station, I'm going to call it y because it's in the y direction. And then they want to know the rate, the distance between the trains. So they want to know how fast the distance between the trains is changing. That distance. I will call that, I don't know, not d. I don't like using d's with I'm using derivatives. So I'm going to call it L for the length apart. So what does it say? This VA statement tells me that x is changed with respect to time 100 meters per hour or minute per minute. Let me double check, per minute. And the train here, what's dy dt? So right here we have the velocity. When we plug in 2, that's going to tell us how fast y is changing with time. That's going to be negative 5 times 4 plus 60 times 2 plus 25. Can I do that in my head? Maybe. That's negative 20, it's 5, 125. I'm getting 125 meters per minute. Okay, so now I have the velocity of train Y, or train B, the velocity of train A. We're just going to keep going here with more information. So Now, what do they want? They want to know how fast the distance between the trains changing L. They're looking for dl dt at time t equals 2. And all these are t equals 2. T equals 2. And so we need an equation with y, L, and x. Clearly, that's Pythagorean theorem, hopefully you see. X squared plus y squared equals L squared. And all three of these, x, y, and L, they're all functions of time. So they're not our variables. Our variable's t, so we have to treat them as functions. What's the derivative of box squared? 2 box times the derivative of box. Same thing, derivative of box squared is 2 box times the derivative of box. Again, 2 box times the derivative of box. Well, I'm going to divide everything by 2. And if I do that, 2 divided by 2 is 1, 2 divided by 2 is 1, 2 divided by 2 is 1. All those are gone. Nicely. I got to create some space here. Let me erase that. So at this point, I just need to fill in everything I know. Do I know x, y, and L? I do know x. It's 300. And I know dx dt. That's 100. Do I know y? Yeah, that's 400. And do I know dy dt? Yes, that's 125. And the last things I'm left with is, do I know L? I can use Pythagorean theorem. L is going to be square root of 400 squared plus 300 squared. I believe that comes out to be 500. So L is going to be 500 meters. And dl dt is what we're looking for. And now it's just a matter of simplifying. So this is going to be 30,000 meters squared per minute. What's this going to be? What, 250, 500, 50,000? If I'm doing my math right. There's a good chance I'm not. We're going to add these up. We're going to get 80,000. I'll make some comments about simplifying. I don't have to be doing all the simplifying. Then I'm going to divide both sides by 500 meters. Those will nicely cancel out. One of those will cancel one of those. 2 zeros cancel out 2 of those. 5 goes to 8 one time, 36, 0. I'm getting 160 meters per minute. Is my dl dt when t equals 2. There's my answer. Now, you could have left your answer as all of this divided by 500. You didn't have to simplify and do all that. Just makes it easier and less chance of making a mistake.